Hello guys, I have already completed the first chapter, that is, now today the second chapter, that is skill. The second chapter is skill. SCALE, that is skill. What do you mean by skill? A scale is a measuring instrument. Understand? So here the scale is a measuring instrument actually. But in our engineering drawing, the types of scales used in engineering to represent various kinds of objects. So actually three types of scale that is used in engineering drawing. Number one is full scale. Number one is full scale. Number two is enlarging scale. Number two is enlarging scale. And number three is reducing scale. Number three is reducing scale. So what do you mean by full scale? Full scale is just like that the so many objects are there. Some objects are very big and some objects are very small. So suppose we want to draw any object which is, suppose this is our drawing sheet. So we want to draw any object. If the size of the original size of the object is, we can draw the original size. We take the original size of the object and we can draw this in our drawing sheet. Then we use full scale and it is denoted by 1:1 scale. 1:1 scale means whatever we drew in our drawing, that is the original size of the object. Understand? Suppose a pen. This is the size of a pen. I am drawing here how far distance from here to here. Suppose this is the length of the pen from here to here. So I am drawing the original size I am taking the original size of this pen and draw here. So this is our pen. You can see, suppose this is my pen. This is the size of my pen. Understand? We take the original size of the original length or breadth of the pen and draw here in our drawing. That is called, we take the full scale. That scale is the full scale, means whatever the size of the drawing, that is the actual size of the object. In that case we use full scale. And what do you mean by enlarging scale? You can see so many small objects are there. So many small objects, just like the parts of a wristwatch. So many small gears are there in a wristwatch. You can see that the in a wristwatch shop that so many small gears in a wristwatch. The size of the wristwatch is just like this. Suppose this is the size of a wristwatch. Understand? And here so many parts inside this wristwatch, and that parts are very small. So many gears. Suppose we want to draw a gear just like that. If we want to draw just a size of this, if we want to draw the gear, you can't understand what is the dimension of this gear. That is very small. In that case, we draw by enlarging the object. We draw, suppose this is a gear, this is the size of the gear, then we can understand the size of the gear of the wristwatch. And this is the small gear. We draw this gear here, means we are enlarging the gear, and draw here. In that case, we use the enlarging scale. In that case, we use the enlarging scale, and that is, suppose 50 is to 1. 50 is to 1. Or suppose 10 is to 1. Means 1 is the size of the object. Original size of the object is 1. Suppose 1 millimeter. Suppose 1 millimeter is the 1 millimeter is the original size of the object, and we draw here by multiplying this diameter into 10, means 10 times bigger. We draw here that gear. So the drawing size is 10 times bigger than the original size of the object. So in that case, so you can see so many parts of a toy, the mechanical toy, so many parts are there, or electronics toys are there. You can see so many parts are there. If we want to draw the parts of a toy, then it is very small in size. We can't draw it properly with exact or accurate dimension. So we enlarge the scale, and we, by multiplying either 10, 20, 1.5, 2, whatever it may be, and we draw the drawing bigger than the original dimension of the object. In that case, we use the enlarging scale. Suppose 15 is to 1, means the original size of the object is 1, but the drawing size is how much? Is 50 multiplied by 50. This is the drawing size, and this is the original size of the object. So here enlarging the object 50 times from its original drawing or original dimension. Understand? Suppose this is 10 is to 1. This is called enlarging scale, means we enlarge the drawing by 10 times from the original dimension of the object. Understand? This is an enlarging scale. Enlarging scale, that is 50 is to 1. Another scale is there, that is reducing scale. What do you mean by reducing scale? Means the drawing size, whatever the original size is, size of the object is very big, but we draw it in our drawing by reducing the size. By reducing the size means, suppose a building. If we want to draw the drawing of a building, the building is very big. We can't draw if we take the original size of the building, original length. Actually, it is a three-dimensional. That is means it has length, breadth, and width. If we take the original length, original breadth, and original height of a building and want to draw in our drawing sheet, then it is not possible. Is it possible? Then it is not possible. So, because our drawing sheet is much smaller than that of a building, understand? So, if we want to draw any building in our drawing sheet, so we have to reduce the scale length of the. So, how much time? Suppose reducing scale, we are reducing the size 1 is to 1 is to 1000, means that if the original length is 1000, either centimeter or millimeter, whatever may be, if the original size of the object is, suppose length, breadth, or length, breadth, or height, anything is you have to take, everything you have to take. So suppose the length of the is 1000 millimeter. Suppose length of any object is 1000 millimeter, but in that case we take 1000 times, we reduce the length of that object 1000 times, and it becomes 1 millimeter. If 5000 is the length of the object, then the drawing size is how much? 1 is to 1000 scale, that is 5 millimeter. Understand? Means it is 1 by 1 is to 1000 ratio. We are reducing the scale into 1 is to 1000 ratio. Means if the length of the object is 5000 millimeter, then we draw here that length in our drawing, we take 5 millimeter. So our scale is what? 1 is to 1000. Understand? Means 5 by 1000. 5 by 5000 means that is 1, that is 1000, equals to 1 by 1000, equals to 1 is to 1000. Understand? So we have to reduce the scale, reduce the original size and make it into the drawing size. If the 1000 millimeter is length, then we have to draw it 1 millimeter in our drawing. Suppose any building or any big machine is there, we can draw it. In that case, if we want to draw the original, we take the original size of the building, and if we want to draw it, then a building size drawing sheet is required. But in practical, it is not possible. Is it possible? It is not possible. That's why we reduce the length of the, that's why we reduce the length by reduce the drawing size is to in by converting taking a reducing scale and converting into the drawing size. So understand that these three scales are used in our engineering. Three types of scales are used in our engineering drawing. So one is full scale, that is 1 is to 1. Enlarging scale, that is either 50 is to 1, 10 is to 1, 2 is to 1, or anything. 2 is to 1, that is enlarging scale. Another one is reducing scale, that is 1 is to 1000, 1 is to 10,000. If we reduce the original size by 10,000 times, that is, then the ratio is what? 1 is to 10,000. Means that we are reducing the original size by dividing it into 10,000, and we get the drawing size. Understand? Now, actually, the classification of measuring scale, these are the engineering scale, and the measuring scale, the classification of measuring scale means we are classified the measuring scale into various divisions, just like number 1, these are the engineering scale. These are the engineering scale. Engineering drawing, we use three kinds of scales. And the measuring scale, what are the classification of a measuring scale? Measuring scale, classification of a measuring scale. Measuring scales are classified into mainly number one, that is plain scale, plain scale that we are used by measure any instrument or any object length, breadth and height. Number two is diagonal scale, diagonal scale. Number three is what? Number three is vernier scale. Vernier scale. Number four is comparative scale. COMPARATIV, comparative scale. And number five is scale of chords. So mainly the plane scale and diagonal scale is in our syllabus. And vernier scale, that is another scale is there, means that is called a vernier. So we can measure a vernier up to maximum, the least is 0.02 millimeter. 0.02 millimeter, that is the least count of a vernier scale, that is 0.02 millimeter. Means we can measure very small distance with the help of this vernier scale. And comparative scale is there, that is we comparing these two, we can measure any distance, that is a comparative scale. Another scale of chords, that it is a measurement of chords. A special type of scales is there, that is called scale of chords. So this is a measuring scale, but mainly these two type of scales are there in our syllabus, that is plane scale and diagonal scale. Diagonal scale, what do you, why plane scale is just a simple scale, and diagonal scale that is used to measure a small distance, that is used to measure a very small distance. So that is called diagonal scale. With the help of this diagonal scale, we can use a very small distance. Actually, diagonal scale is used to measure actually three consecutive units. Understand? Means one unit and its subdivision and further subdivision in one scale. You can understand. Diagonal scale is used to measure three consecutive units. Suppose kilometer, suppose 100 kilometer we can measure, 10 kilometer and 1 kilometer. Understand? Means kilometer, hectometer and decameter we can measure by a single scale, that is diagonal scale. Mean with the help of, suppose we want to, if we want to measure kilometer as well as hectometer and decameter also by a single scale, then in that case we use diagonal scale. Means that we use three consecutive units we can measure with the help of this diagonal scale. Understand? Then in scale, you have to know so many formulas are there. First of all, you have to know the formula of representative fraction. What do you mean by representative fraction? And in short term it is called RF, representative fraction. Representative fraction means we can also call it RF. RF. What is the definition of RM and what do you mean by representative fraction? It is very interesting thing and it must be known by you by drawing a scale. Mathematically, RF equals to means representative fraction equals to what? Now it is the ratio of drawing size of the object to the actual size of divided by actual size of the object. Means it is the ratio of drawing size to the actual size of the object. Understand? Suppose in any object is there whose length equals to original length is 100 or 1000 millimeter. Suppose 1000 millimeter, and we want to draw this 1000 millimeter in our actual length. Actual length is how much? 1000 millimeter. But we want to draw it. Actually, we are represented it by in our drawing that is 1 millimeter. It means drawing size. Drawing size is how much? 1 millimeter. So in that case, what is the RF? RF is equals to what? RF equals to drawing size of the object by actual size of the object. So drawing size of the object is how much? That is 1 millimeter. And actual size of the object is how much? That is 1000 millimeter. Understand? So we omit millimeter and millimeter. So it is sorry. It is 1 by 1000 means it is 1:1000. So the RF is what? RF is 1:1000 and it has no unit. Actually, RF has no unit. Why? Because it is the ratio of two length. It is the ratio of two length. So it has representative fraction has not any unit. Understand? Another formula is there that you have to know that what should be the length of the scale in our drawing. Maximum length of the scale. So there another formula is there. So length of the scale equals to how much? Length of the scale equals to what? Length of the scale equals to, it is represented by capital L, equals to what? It is RF means representative fraction into maximum length to be measured. It means that if we want to measure the maximum length, suppose we have to draw a scale. By this scale we can measure how much length, maximum length, that is the maximum length of the scale. And in the scale, if we want to draw the length of the scale, that should be RF and maximum length to be measured. So it is another formula that is required to draw a scale. So two things are there. One is RF, that is two formulas are there. One is RF, that is drawing size of the object by the actual size of the object. Means it is the ratio of drawing size of the object to the actual size of the object. So it is called representative fraction, means RF. Another formula is there, that is the length of the scale. Suppose we want to draw any scale, how we can calculate the length of the scale? So if we know the RF and maximum length to be measured, how much length to measure, measurement length, then we can easily calculate the length of the scale. Understand? We can easily calculate the length of the scale. So these things you have to remember to draw a scale. So next day I will tell you how you draw a scale. Understand? So thanks for today.